Welcome, my lovely geometers, to our 6.6 video, which is Use Proportionality Theorems. Today's video, we're going to use three different theorems that are going to help us set up some proportions. So the first one is called the triangle proportionality theorem. It says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so all that means is, if I have two parallel sides, well, I have BE, which is parallel to CD, it divides the sides proportionally. We've already seen this before. Our proportion is AB, small side of the triangle, over AC, the corresponding large side, equals AE, the small side, over AD, the large side. So we've already done that in previous sections before. Now we're just putting it into a theorem. So example 1, it says, in the figure above, BC is 9, AE is 4, ED is 6, find AB. Okay, so small side AB is x over this entire side. This one's tricky. It's x plus 9, because that's the whole side. And then small side is 4. All over, large side is 10, 4 plus x. And now I'm ready for my cross products. I have 10x equals 4 multiplied by x plus 9. This becomes 10x equals 4x add 36. If I subtract 4x, I get 6x equals 36, which tells me x equals positive 6. So again, that's nothing new. This is something that we have been doing. So looking at example 2, it says find the value of x in the figure below. That will make BD parallel to AE. Okay, so small side is 4 over large side is 4 plus x equals small side is x over large side, which is x plus 9. Okay, this one is going to be more difficult, so stick with me. I have 4 multiplied by x plus 9 equals x multiplied by 4 plus x. So this becomes 4x add 36 equals 4x add x multiplied by x is x squared. Okay, I'll notice if I subtract 4x from both sides, they both cancel. So I get 36 equals x squared. If I take the square root, I get x equals positive 6. Okay, so we have two more theorems. Next theorem says if three parallel lines intersect two transversals, so here you can't see it very well, but these three lines are parallel, and then we have the first transversal and the second transversal. They divide the transversals proportionally. Okay, so the proportions are AB corresponds to BC, DE corresponds to EF. So that's not too bad. That's pretty similar to the theorem above. This next theorem is the one that's going to be a little more difficult. It says if a ray bisects an angle of a triangle, so if this angle is bisected, then it divides the opposite side, so opposite side, into segments whose lengths are proportional to the length of the other two sides. Okay, so we're comparing whole sides to the intersected sides, or intersected side in this case, which is AC. Okay, so AB, this whole side, is going to correspond to AD because it's connected to AD. And then this whole side, BC, is going to correspond to DC, the little part that it is touching. And then again, we would use cross products to solve this. So I think it's best if we just jump in and complete some examples. So flip the page, please. Okay, so let's look at example number 3. It says, in the figure below, AB is equal to 17, BC equals 11, DE is 3x minus 2, and EF is 5x minus 6. Find the value of x. Well, I know AB and BC to go together, so I have 17 over 11 equals, and then DE and EF go together. 3x minus 2 over 5x minus 6. And then I'm going to do cross products. I have 11 multiplied by 3x minus 2 is equal to 17 multiplied by 5x minus 6. This becomes 33x subtract 22 equals 85x subtract 102. If I add 102, I get 80 equals, and then I subtract 33. I get 52x. So overall, I get x equals 80 over 52. If I divide both by 2, I get 40 over 26. Divide by 2 again, I get 20 over 13 equals x. That's my final answer. It's okay that it's a fraction. Sometimes we're going to get fractions. I know sometimes we think that means we did something wrong, but no, that's right this time. Okay, right now, pause the video and try example 4 on your own, please. Okay, let's see how we did. These should have corresponded, so 15 over 18 equals. These should have corresponded, 16 over x. It's okay if you had them reversed, but you should have 18 multiplied by 16 equals 15x. If not, then you did something wrong. 18 multiplied by 16 is 288, so I get 288 equals 15x. If I divide by 15, I get x is equal to 19.2, which is 96 over 5. So hopefully you got that one right. If not, hopefully you now see what you did wrong. So let's move on. We have 2 more examples. Okay, we have 2 more examples and then you are done with this video. So it says in example 5, in the figure below, WN is the angle bisector of angle W. So I'm going to mark that. Find the length of NO. Because I want to know NO, I'm going to call it X. Okay, 14 is one of the sides. That corresponds to the little part that it touches, 4 root 2. The other side is 7 root 2, which goes up here. That corresponds to this little side, NO, which is X. So in the numerator we have the sides. Denominator we have the parts of the third side. And now I'm ready for my cross products. So I have 14x equals 4 multiplied by 7 is 28. Root 2 and root 2 is root 4. But remember that the square root of 4 is just 2. So I get 14x equals 28 multiplied by 2 is 56. If I divide by 14, I get x equals 4. Okay, and then let's look at example 6. It says find the length of OY if JY equals 20 in the figure below. Again, this is supposed to be an angle bisector. You kind of can't see it though. Okay, we want to know OY, so we marked it X. Well, if the entire side JY is 20, then JO is going to be 20 subtract X. So right now, pause the video and see if you can finish this example, please. Okay, let's see how we did. 7 is one side. That touches the little part 20 minus x. The other side is 13, and that touches the little part x. Now we're ready for cross products. I get 7x equals 13 multiplied by 20 minus x. So 7x equals 260 subtract 13x. If I add 13 to the other side, I get 20x equals 260. Dividing by 20 gives me x equals 13. That means this x part is 13, and 20 minus x is 7. So OY in this case is 13. If you got anything above 20 or you got a negative number, that should have kind of clicked in your head that you did something wrong. So hopefully it did. If we made a mistake, hopefully we know what mistake we made. If not, good job. Please bring any questions that you have to class tomorrow. We will make sure to go over them. See you tomorrow.